Here we go, 88, 89, and 90. 88 is your favorite problem. So we have a guy, 6 feet tall. So let me label that here. So he is 6 feet tall. And he's walking away at a rate of 4 feet per second. So something is changing 4 feet every second. What's changing? We have to define what's changing 4 feet every second. So I'm going to define it as a distance from the light post. Now you can pick other reference points, but the light post is given. It's so easy. And this distance I'll call x. So what's changing at 4 feet per second? It's x changes as time changes. So we have dx dt is 4. And x is increasing because he's walking away. So that's going to be a positive rate because the derivative is positive if a function's increasing. So we've taken care of that. Now we have the height of the street light is 15 feet. So this distance is 15. And they want the rate at which the person's shadow is lengthening. So the length of the shadow, we have to give that a name. I don't want to do S because my S's look like 5s. L, I like L. L will represent the length of a shadow, so we're looking for the rate of change of L with respect to T. So in this one, I told you there were 4 major types of equations that you would use. So we need an equation with X and L. So let me list the 4 types. 1, Pythagorean theorem. That's sad. Math teacher doesn't know how to spell Pythagorean. I have to look that up. That's embarrassing. So 2, it's often going to be like an area or a volume type situation. C, we also have like trig equations. That could be like sine, cosine, tangent, and things like that. Okay? I see that's a 1, 2, C. You can tell I'm on my game today. How about 1, 2, 3? I think I was rattled by my lack of knowing how to spell Pythagorean. And the last common one will be similar triangles. Let's go to Mr. Pythagoras. Wow, that's pretty bad. All right, so if you look at this problem and try all your different options, you will see that Pythagorean theorem is not going to get you anywhere. It's not an area or volume situation. Trig, we don't have any angles, so that's not going to help us. It's going to be similar triangles. And so let me draw the situation here. Here's my man. This is 15. This is 6. That's X, and that's L. And this distance that x is there to there, and L is there to there. So this whole distance is x plus L. I'm going to break these triangles, separate them out so you can see them better. So I have the big triangle, which is 15 and x plus L. And then we have the small triangle. It's beautiful, isn't it? 6 and L. And so these triangles are similar. Therefore, all their sides are in proportion. So we know that, let's do this way, x plus L is to L. Let me write that down as 15 is to 6. I'm going to multiply both sides by 6L. L's cancel, 6's cancel. That's going to get me 6x plus 6L equals 15L. I'm going to subtract 6L from both sides. Divide both sides by 3. Now, I'm going to take the derivative of both sides with respect to t. Now, what you have to realize here, that x is a function of time. As time goes on, x changes because he's walking away from the light post. And L here is also a function of time because as he walks away from the light post, his shadow gets longer and longer. And so when you take the derivative of this, those are actually functions. The variable that you are actually using is t. That's my variable. So when I take the derivative with respect to time of the left side, 2 is a constant, so I copy the constant. The derivative of x with respect to time is, by definition, dx dt. And the derivative of L with respect to time, by definition, is dl dt. And now I plug in the known values. Let's see, I'll use that color. So we know dx dt is 4. And we get 2 times 4 equals 3 dl dt. Divide both sides by 3. And dl dt is 8 over 3. 8 over 3. Okay, so what is 8 divided by 3? Oh, this is a calculator problem. You do this on your calculator. 3 goes into 8 twice, so that's going to be 6 with the remainder of 2/3. 6. Wow, that's pretty embarrassing again, Yoshida. 3 goes into 8 twice. That's better. That's a remainder of 2, so it's 2/3. So it's 2.6667. So we found our answer. Bam, your favorite related rates. They're not bad once you get the hang of it. All right, 89. You have a particle moving along a line, and we have its acceleration. We have the velocity at t equals 0, and they want the velocity at t equals 3. I'm hoping you see it. So this here is saying v of 0 is 5. These two here is saying, hey, what's v of 3? And this is really v prime of t. And so, do you see it? The fundamental theorem of calculus. What's the velocity at 3? Well, it's the starting velocity at 0 plus how much the velocity changes from 0 to 3. But this is 5, v sub 0 is 5, and v prime of t is actually the acceleration function. So I'm just going to pop that in my calculator. I haven't done it yet. Forgive me. I'll do this quickly as I can. 1t plus 3 square root t cubed plus 1, bam. So in my calculator, 5 plus math 9 from 0 to 3. And it's going to be y1 for my function. I get 11.710. Beautiful right there. I believe that's 2 problems, 1 more to go. Or is that 3 already? I don't know. This might be a 4. I guess I'm getting tired. All right, number 90. Here's a problem. This is our problem. F of x, that's fine and dandy, but this is not x, it's 2x, and our variable's x, so we have to rewrite this and let u equal 2x. That means du is going to be 2 dx. And so here's my question. Do we have 2 dx? Do we have this? If I do that, now I have a 2 dx. So here's what happens. I can substitute things out now. Use substitution. The 1/2 remains. This is just u, so I replace that with u, and this is du. But here's the next problem. That 6 and that 12, those are values of x. When I have a du, I need to have values of u here and here. So when x equals 6, u equals 2 times 6, that's the formula, 12. When x equals 12, u equals 2 times x, u is 24. So that changes to 12 and 24. And this all equals 10. I'm just substituting things out. I'm going to multiply both sides by 2 to eliminate that 1/2. And we have our final answer. The integral from 2 to 24 of f of u du is 20. Now, you might be bothered that we have u's and not t's, but the variable does not matter. It's just a dummy variable. We can just replace all the u's with t's and it comes out the same. So we have our answer right there. And hopefully that was 3.